Hey, welcome to our talk on sampling that actually makes sense. Today, we're digging deep into the world of rational sampling and rational subgrouping, terms that sound pretty technical, but trust me, they affect everything from quality control in a factory to whether a scientific study really means what it says.
Yep, we're pulling from quite a few documents by Donald Wheeler. His articles and papers in Quality Digest and all that. The guy's a legend in the world of data and quality. And he's definitely got opinions about how you're supposed to pick and group your data.
That's for sure. So, what's the point of all these pieces? They basically show that if you don't pick the right data in the right way, your stats and all the cool graphs you make are just, well, kind of a waste of time.
Totally. It's not just about the numbers or the formulas. Like with rational sampling, if you just grab a few random bits and hope they tell you the whole story, you're probably missing the point. And when it comes to rational subgrouping, grouping it's a must if you actually want to tell what's real change and what's just noise, right?
Exactly. And here's the kicker. These mistakes aren't just random flubs. They can lead to some massive screw-ups. Think accepting a bad batch of product or making a change in your process that you think helps, but actually just confuses things more. So let's start with rational sampling. What does it really mean? Wheeler says that it comes down to making sure your sample actually represents the whole process, not just the easier parts to grab, like the top of the pile or just what you see first.
Right, like if you only check the cookies on the ends of a baking tray, you're not getting the big picture of how your oven's working at all.
Exactly. He gives this example about acceptance sampling in pallets of flooring. Workers would just grab the boxes at the corners. Sure, the boxes on the outside may look great because, people know those get checked more often. But what about the ones in the middle?
So what's the risk there? You approve the palette based on a few perfect samples, but hidden inside are boxes full of duds.
Exactly. And rational sampling is especially important when you deal with big data streams. Like when you have sensors capturing temperatures every second. Do you actually need all of them, or do you grab them rationally? Just because you can sample at a crazy rate doesn't mean it's useful for control charts.
Make sense? You end up with a mountain of data, but if you don't pick samples properly, your charts get all weird, right?
Yeah, like you want your samples to reflect the process. So when you look at a chart, you actually see signals and not just a bunch of meaningless dots. It's all about making decisions you can trust, rejecting a batch if something's off, catching a new issue, stuff like that.
Okay, so how about rational subgrouping? That's grouping your data so things are together, right?
Exactly. So say in a factory, you make different products or batches. Don't lump them all into one chart. Otherwise, you're comparing apples and oranges, and your chart might just be pure chaos.
That's so true. In short run SBC, the stuff for lean manufacturing where you're making lots of different products, Wheeler talks about Z charts and difference charts. You need rational subgrouping so the results make sense. Otherwise, you'll react to false alarms or completely miss the real problems.
And he has these wild examples, like if you split your data for two products with different target values, but then combine them on the same chart, nothing lines up. He says rational subgrouping is the fix. Clearly label each group, set separate limits, and look for actual trends.
Yeah, and even when you're using fancier stats like ANOM, analysis of means, or running a gauge study, you can't just mash up data from all your operators or machines. You need subgroups that are meaningful, or else your decision on which machine is best is basically a shot in the dark.
Right. Wheeler even shows that the common ratios in some measurement studies are nonsense if you ignore subgrouping. It's math, but it just doesn't work unless your groups make sense. There's also the issue with surveys and observational studies. Like, you know those graphs where every year the numbers go up and down? You just compare year to year without accounting for the natural variation or rational subgrouping of your data. You might call out fake trends.
Oh man, we see that all the time. Some new headline every year claiming a crisis or a miracle just because this year's number moved a bit.
If you use a control chart with properly subgrouped data, you'll actually know if there's a real shift or if it's nothing but noise, and you avoid making a ton of pointless decisions or wild predictions.
So all the charts, stats, models, they only mean something if you start with data that are grouped and sampled rationally. Otherwise, it's fiction.
Quick recap. We covered why rational sampling and rational subgrouping are, honestly, the foundation for quality measurement. If you skip them, you're just rolling the dice with your decisions.
Thanks for joining us for this walk through the world of meaningful data. Next time you look at a chart or a study, just ask, did they sample and group these numbers rationally? That's where the truth really starts.